Welcome back to the channel. In today's video, we will look at solving lead code problem number 138, copy list with random pointer. Let's go over the question. A linked list of length n is given such that each node contains an additional random pointer which could point to any node in list or null. Construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to the new nodes in the copied list such that the pointers in the original list and copied list represent the same list state. None of the pointers in the new list should point to the nodes in the original list. For example, if there are two nodes x and y in original list where x dot random points to y, then for the corresponding two nodes x and y in the copied list, x dot random should point to y. Return the head of the copied linked list. The linked list is represented in input output as a list of n nodes. Each node is representing as a pair of value and random index, where value is an integer representing the node value, random index is the index of the node that random pointer points to. Let's look at example 1. This is the linked list which is represented by this input and output is this, where the values of input and output are same, but in the output the node objects are different. Let's understand the problem using this example test case. We need to create copy linked list of original linked list like this. The copy nodes are yellow colored. The intuition is to create copy of nodes of original linked list and maintain a mapping of original nodes to copy nodes to set the next and random pointers of the copied nodes. For mapping, we have discussed in previous videos, HashMap is the best data structure because it provides faster lookup of O of 1. This solution can come intuitively to you by practicing similar problems and learning how different languages do deep copy of objects. Next, let's jump into the visualization of the solution. We will start by initializing HashMap to empty. We will traverse original linked list starting with first node 14. In first pass of linked list, we will create clone nodes of original linked list with only next pointer and maintain a mapping of original node to the copied node. We create a copy node of current node and make entry in HashMap to maintain mapping of original node to copy node. The clone node here is a new node object with same value as original node value. We move the current node pointer to next node in original linked list, which is node 17. We create a copy node of current node 17 and make entry in HashMap. We move the current node pointer to the next node in original linked list, which is node 19. We create a copy node of current node 19 and make entry in HashMap. We will make a second pass on original linked list and this time we will set the random pointer of all the copy nodes. We will start with pointing current node to the first node 14 in the original linked list. For better understanding, let's just focus on current node and the hash map and erase everything else. We will get the current node's clone from the hash map. Next, we get the random node from random pointer of the current node. Then we get the random node's clone from the hash map. Now we make the random pointer of current node's clone to point to the random node's clone. This is the state we will be in after setting the random pointer of cloned yellow node 14. We move our current node pointer to next node 17 in original linked list. To set the random pointer of node 17, we will erase everything except the current node. We will get the current node's clone from the hash map. Next we get the random node from random pointer of current node. Then we get the random node's clone from the hash map. Now we make random pointer of current node's clone to point to random node's clone. This is the state we will be in after setting the random pointer of cloned yellow node 17. We move our current node pointer to next node 19 in original linked list. Next, let's set random pointer of yellow node 19. We get the current node's clone from the hash map. Next, we get the random node from random pointer of current node. Because random node is null, it won't have an entry in the hash map, so we ignore doing any further operation. Because random of current node's clone is not set, so by default it will point to null. This is the final state after setting the random pointer of all cloned nodes. We'll stop our traversal of original linked list because next pointer of current node is null. Now we will simply return the head of the cloned linked list, which is the yellow node 14. Let's look at the code of the solution. At line 3, if the original linked list is empty, then we return none. Then we create an empty hash map. We initialize variables current node, copy previous to head and none. Then we have a while loop to create copy nodes with next pointer only. And we do that by creating a new copy node with its value being that of the current node. Then we maintain a mapping of current node to copy node in original to copy variable. We keep track of previous copy node to link its next pointer to the copy node. Then we have the second while loop, which is a second pass on the original linked list to set the random pointer of the copy nodes. We do that by setting the random pointer of current copy node to the random copy node. And then we move the next node in the linked list. And then finally we return the head of the copied node. This solution can be modified to be done in one pass. But for easy understanding and simplicity, I chose to present this solution with two pass. Modifying the solution to one pass will not improve the big O time complexity but will reduce the number of operations. Let's do a complexity analysis of our code. The total time would be O of n because we traverse all the nodes of original linked list to create a deep copy. The total space will be O of n because of the storage taken by the hash map to maintain the mapping of the original node to the copied node. Thank you for watching this video and stay tuned.